Hello, we are about to present you on our information retrieval assignment. Now, we will be moving on to crawling. The crawled queries were selected based on popular job searches for different income groups such as high, middle and low income jobs. This aims to provide a more holistic overview on various jobs in the market today. The crawled corpus also comprises of 49,000 records and 933,000 words approximately. After vectorization of the text corpus, there are 22,957 unique words. Each of the crawled record provides a substantial amount of information for the users to view such as the job title, job description, country location, the time the job was posted and more. Take for example, one of the query for high-income job would be software developer, where the crawler will produce a JSON output and later, merge into a static text corpus. In our project, Whoosh is utilized to do the indexing part. Whoosh is a library of classes and functions for indexing text and then searching the index. It allows users to develop custom search engines for their content. In the chart above, the blue color parts are done by Whoosh, which requires documents as input. For indexing, inverted index is used in Whoosh. It maps terms to the documents that they appear in. When the user adds documents to an index, instead of integrating the new documents with the existing documents, Whoosh creates a new segment next to the existing segment. Then when the user searches the index, Whoosh searches both segments individually and merges the results so the segments appear to be one unified index. The schema specifies the fields of documents in an index. All these fields are stored since we need to display the data in these fields in the results. After indexing is done, query is conducted using Whoosh to search for jobs. A web-based user interface is implemented using Django and Python. This is the home page, with a simple search box. We can search for a term or just click the search button without input to see the list of jobs available. Let's just click the search button. This is the search page with the search results. We can enter query terms for search in the search box. Let's search for the term software. A list of jobs containing the word software are shown. There are a total of 23,216 jobs found. Then let's say, after browsing through the list of jobs, we are interested in the jobs in accounting type and located in India. So, we select the terms in the filter boxes and filter the results. This narrows down the matched jobs to 4 here. Then we can click on the job title to view the details of the job. A link to the original website is also provided to read more information. Besides simple search and filter, we can search for partial match of terms and jobs. For example, we can use Finance to search for jobs containing finance and financial. We can see that jobs of both financial analyst and finance lawyer are shown. We have also empowered the users to have more control over the search results. For examples, a plus sign can be used to get the intersection of 2 query results. A minus sign can be used to get the search results of the first query term, except those also exist in the search results of the second query term. A or sign can be used to get the union set of the results of the 2 query terms. An additional feature was having the user search for jobs based on his resume. Users could find the most suitable job postings based on his or her resume, by inputting it. This was accomplished using scikit-learn's libraries, in which we vectorized both the entire corpus and his resume into TF-IDF vectors. We then performed cosine similarity between the two. The top 20 results are returned. To see a demonstration, let's submit a accounting student's sample resume. Most of the job postings suggested were accounting positions. This is probably because the terms accountant and accounting was frequently found in the resume. Such terms have high TF-IDF scores, leading to a higher cosine similarity score too. For classification, job postings were classified into career types and had 21 different types of careers. We manually labeled 1,400 job postings and made use of scikit-learn's stochastic gradient descent algorithm to perform the classification. First, the algorithm was used to train a support vector machine model. Next, we used the trained model to classify the entire corpus. Some of the labeled data was set aside to test the accuracy of the classification. The results of the accuracy test are as shown. Support in this chart refers to the number of labeled entries in the test set. The classifier attained an F-measure score of 91%, which meant the classification was pretty accurate. Most categories could be accurately classified, although those with few data in the test set weren't. For example, arts and design had an F-measure score of 0. Classification of the entire corpus of 48,965 documents only took 3.98 seconds to classify.